In the midst of the large show of the universe, we waver on the cusp of Earth, breaking exposures that obligation to regulate our viewpoint on the universe. The presence of the James Webb Space Telescope fosters the volume of our splendid evaluation, assessing further into the preferred bits of knowledge of reality than any time expected. Leaving on this new pursuit via James's understanding, we offer an individual's look at the unusual early universe. Out in this manner, depict trendy, incalculable standards as we enjoy into this illuminating location. The mosaic of our appreciation spreads out, revealing unconventional plans and disguised intricacies. They oblige us as we plunge great into how James Webb simply perceived large plans that should not exist. Could you ever imagine investigating a time system, revealing memories from age to work out insistently? The James Webb Space Telescope has performed basically that. It is, for the most part, a significant field picture constituted of a mosaic of 690 man outlines. It depicts a restore of SK in area, the giant scope with typically on multiple occasions more noteworthy than its ancestor. It's like keeping in full-size interstellar jigsaw puzzle in which every piece is a precise universe from the early universe. These photos gift a complex, complicated dance of systems, some of which existed essentially in sizable quantity of important time spans after the high-quality impact. Their sensitive shimmers are a quiet affirmation to their distance and age, revealed by means of the unrivaled infant responsiveness of the near-infrared digital camera. This observable and massive leap in bombastic evaluation yields remarkable reconsiderations into the universe's nent tales as much as now. Maybe the satisfactory divulgence before 100 prolonged lengths of it is that our domestic to zero in at the universe changes. What is more, it makes with time, not definitely in minor unimportant ways like stars shifting about, fuel hazes pressing, and large stars bombing hopelessly in tragic impacts. No, our entire universe has changed its fundamental appearance at least more than one times within the remote beyond, really converting its inside nation at an unusual inescapable scale. Take, for instance, the truth that at one time in the overcast, iller past, there had been no stars. We understand this crucial fact in light of the way that of the presence of the unfathomable microwave basis, a shower of sensitive however innovative radiation that soaks the complete universe. Assuming that you enjoy an inconsistent photon, a smidgen of mild, there's an awesome opportunity it is from the significant microwave foundation. That mild takes up extra than 99.99% of all the radiation in the universe. It's an extra from when the universe become only 27,000 years antique and improved from a hot demanding plasma right into a honest soup with no wonderful or negative rate exchange conveyed white-hot radiation. That all through the scope of 13.8 billion years chilled and stretched out off into the microwaves, giving us the status quo mild that we will understand today. On the season of the presence of the cosmic microwave basis, the universe becomes round 1/1,000,000th its ongoing volume and substantial number of degrees. Fact be informed, it was too essentially uniform to bubble with density differences. No more than one segment in 100,000. So now not conclusively a country in which stars should joyfully exist within the duration following the shipping of the cosmic microwave foundation delicately known as WMX in area science circles, the universe turned into in an abnormal state. There has been a consistent shower of white-hot radiation. However, that rotted part became hastily cooling as the universe went on with its relentless development. There has been faint anticipated final results striking out, disdaining its own business, and there has been the at this factor independent fuel, basically hydrogen and helium finally set freed from its fights with radiation and loose to do what it happy. Thankfully, it didn't need to fasten within the early universe. Little quantum risks reached out to turn out to be only contrasts in thickness. And why that befell is a tale for one greater day. These tiny thickness contrasts didn't impact the more noteworthy cosmological benefit. However, they impacted the presences of that truthfully minded hydrogen. Any fix that became to some degree denser than everyday, even by using an insignificant little piece, had to some diploma greater grounded gravitational draw on friends, upgraded pull, requested more fuel to sign up for the celebration, which elevated the gravitational energy, which engaged notably more acquaintances, and so forth like tremendous tune at a nearby celebration going tons the identical manner in alarm. Song to help more rares throughout an sizable wide variety of years. The rich gas were given more giant, and the mournful gas were given less fortunate through vital gravity. Little thickness contrasts created, building the first big player of Be Counted, and hard out their environments somewhere. Some part of truthfully minded hydrogen were given lucky, preserving layers resulting to overwhelming layers on itself. The most profound center came to a vital temperature and thickness. Using tangled structure, accomplishing off a nuclear fusion and changing over the harsh substance into helium. That savage cycle, too, conveyed a touch of strength, and in a burst, the leader big name become added into the world. Apparently starting from the hidden dozen minutes of the Amen blast, nuclear reactions happened in our universe, new wellsprings of light dotting the universe, flooding the once void voids with radiation. These new wellsprings of radiation re-energized the honest hydrogen that filled the universe. All through the meant epic of reionization, through gravity, extra and greater eccentric plans emerged, constructing a great big weaving of universes. In the meantime, the entirety endured to fly isolated. The stargazer Edwin Hubble looked out throughout the 192s that the universe is broadening, and in the past due 1990s, his namesake, the Hubble Space Telescope, tracked down affirmation that the augmentation is rushing up. Recall the universe as some part of raisin bread. It begins as a combination of bloom water, yeast, and raisins. Whilst you merge these decorations, the yeast starts respiratory, and the element begins to upward thrust. The raisins inside it alternative for structures, broadening similarly, remote from one another as the component fosters. The Hubble telescope saw that the piece is rising of all time faster. The raisins are flying isolated at a rate that goes against their gravitational interest. This speed increase emits an impression of being pushed by the horrible strength of room itself. Visitor faint energy, which is wooden in general through the Greek letter lambda, plug values for lambda cold weak matter, average Be Counted, and radiation into the territories of Albert Einstein's infashionable hypothesis of relativity, and also you get a model of how the eye encourages this lambda cold weak count number. One procedure for trying out this image is via searching at, in particular, remote monstrous structures, doubtful from thinking again to the primary not many 100 million years after the tremendous a case that started out at all. The universe changed into more truthful than its headway, more trustworthy to analyze towards assumptions. Anyhow, as examiners make use of James' Internet to dive into the underlying segments of the universe, they observed something that shouldn't exist. These dazzling exposures then at that point put the educational neighborhood in issue, in that they have to examine the very fundamentals of what their acquainted cosmology, explicitly nearly following the net. Telescope completely grew to become on in July 2022. James W.G.'s astounding infrared mindfulness found out the susceptible glints of universes in reality from the a long way off universe that had shaped essentially various a broad time frame after the significant impact. Area specialists had expected such accomplishment results to emerge much more at ease. Anyways, more than speculated, there was an effect of facts. Those early outcomes take place so rapidly considering the manner that analysts utilized a smart vital path to check tremendous distances. Cosmologists for the maximum component caught down, limitless path through logical Ly comparing purple shift, a loosening up of a universe's light towards the pink cease of the electromagnetic attain. Because of the universe's improvement, but this requires the advent of social occasion and investigating and infinite systems come to a time-consuming and unpretentious technique called spectroscopy. The James Webb Space Telescope's fireplace hose of revelation became truly fueled via cruder quicker photometry, primarily based techniques that essentially utilize clean combinations in a system's brilliance to actually test their crimson exchange. As such, even as the photometric outcomes came thick and rapid the preceding summer, the spectroscopic results have began streaming, however, with the aid of an extremely restricted aspect out as of now at any rate, with spectre primarily based distances near via from something like 12 candidate researchers are locating that maximum value determinations are matching the early photometric effects. The most current appropriated in Nature Astronomy certifies previous distance measures for more frameworks recognized by the Farad Massive Extragalactic Outline as shown by means of Emma Curtis P. of the School of Hure in Britain, who drove the spectroscopic results. We have been accepting that this may have the decision to do it within the critical begin, fairly couple of months. This telescope was simply fantastic. Of the four, the most distant is united with the pretty stumbling named Gonzi. It has a crimson shift really worth of 13.2, which means we are seeing the shape because it appeared most effective 320 million years sometime later the big explosion. That excessive crimson shift makes Jade Zero the most far off at this point regarded in the universe. A report that the James Webb Space Telescope seems set to break all over again, yet one inescapably that highlights space professionals, so the nuclear focuses collectively in inspired. We at this point know for unequivocal we try a period of the universe. No human has it any direct looked at, advance towards its staggering, says Peter Van Destruction of Yale School. This cosmic shape, he interestingly notes, I just slightly more settled from our point of view than the general time sharks have existed on the world, approximately 300 million years. As such, you move from nothing to those unquestionable universes in the glint of an eye. But not all high redshift competitors in admirable systems were so fortunate, which highlights cosmologists' early consideration in July. Another blueprint, referred to as the endless movement early delivery technology, evaluated by Felstein, featured a possible universe at a redshift of 16.4, only 240 million years after the giant blast. Coming to fruition, spectroscopy has shown that settlement was astray, as revealed in late March in research led by Pablo Arabel and cosmologists at the National Science Technology Established or No Lab. The world is everything to thought of a dusty shock and waves. That so far this universe is considered a dusty joke, operating at a redshift of 4.9, still bright but not record-breaking 1.2 billion years after the giant impact. Raised levels of star development are made of the early universe. In each of these universes, the team tracked the formation of billions of solar masses, which were believed to have an estimated 75 million years after the giant blast, and universe seen by looking researcher concluded. I apologize for the confusion earlier. It seems there's some issue with the text you've provided, making it difficult to interpret accurately. However, I'll try to continue from where we left off. Made of the early universe. In each of these universes, the team tracked the formation of billions of solar masses, which were believed to have an estimated 75 million years after the giant blast, and universe seen by looking at. Researcher concluded that these early universes are minimum of times of the standard universe, explaining that these early universes have presented challenges and studied that as some he and that have hoped. The discussion appears to focus on observations made possible by the James Webb Space Telescope, JWST, and its impact on our understanding of the early universe. Here's a structured continuation. The James Webb Space Telescope, launched in 2022, has significantly advanced our ability to study distant galaxies and the early universe. It uses infrared technology to peer deep into space, allowing astronomers to detect faint signals from galaxies that formed billions of years ago. This capability has led to groundbreaking discoveries, such as identifying galaxies at record-breaking distances with redshifts as high as 13.2. These observations challenge previous assumptions about the timeline of cosmic evolution. For instance, galaxies observed at such high redshifts formed just a few hundred million years after the Big Bang, pushing our understanding of when and how galaxies first emerged in the universe. Moreover, spectroscopic data from JWST have confirmed these distant galaxies' distances and characteristics, validating earlier photometric measurements. This confirmation is crucial for refining cosmological models and understanding the processes that drove early galaxy formation and evolution. The telescope's ability to conduct rapid photometric surveys has provided a wealth of data quickly, enhancing our knowledge of the early universe's dynamics and structure. This includes insights into the epoch of reionization, when the universe transitioned from a neutral state to one dominated by ionized hydrogen. In summary, the James Webb Space Telescope represents a significant leap forward in observational astronomy, enabling scientists to explore cosmic epochs previously inaccessible. Its findings continue to reshape our understanding of the universe's origins and evolution, offering new perspectives on fundamental questions in cosmology. Early universe observations. Formation of early galaxies. The JWST has observed galaxies at redshifts greater than 10, meaning we see these galaxies as they were just a few hundred million years after the Big Bang. These early galaxies appear to have formed stars at a much faster rate than previously expected, suggesting that star formation in the early universe was more efficient or occurred under different conditions than in later epochs. High redshift galaxies. The discovery of galaxies with redshifts as high as 13.2 indicates that these galaxies existed only about 320 million years after the Big Bang. This challenges the understanding of galaxy formation timelines and suggests that the first galaxies formed very quickly after the universe's initial expansion. Technological advancements. Infrared observations. The JWST's near-infrared camera, NIRCam, and mid-infrared instrument MIRI allow it to detect faint and distant objects by capturing light in the infrared spectrum, which is essential for observing high redshift galaxies whose light has been stretched into the infrared by the universe's expansion. Spectroscopic confirmation. The telescope's spectroscopic capabilities, including the near-infrared spectrograph, NIR-SPEC, provide precise measurements of the redshifts of distant galaxies. This allows astronomers to confirm the distances and properties of these galaxies with unprecedented accuracy. Cosmic reionization. Epoch of reionization. Observations from the JWST provide valuable data about the epoch of reionization, a period that began about 400 million years after the Big Bang and lasted until about 1 billion years after the Big Bang. During this time, the first stars and galaxies formed and ionized the surrounding hydrogen gas, making the universe transparent to ultraviolet light. Cosmological implications. Dark matter and dark energy. The findings from JWST have implications for our understanding of dark matter and dark energy. The formation and distribution of early galaxies provide clues about the nature and behavior of dark matter, while observations of the universe's expansion contribute to our understanding of dark energy. Cosmological models. The unexpected rapid formation of galaxies and their large masses suggest revisions to existing cosmological models. These models must account for the efficient and early star formation and the assembly of massive galaxies in the universe's infancy.